Hey everybody, and welcome to Chapter 2, Data Types and Missing Values. So we're going to begin with data types here. And every single value in a pandas data frame or series has a data type. So there are five common, or more common I should say, data types. There are actually other data types that are not in this list right here, but they are not as important. And we will get to them and explain them when they are needed and when we have a problem that uses them. So a Boolean is simply either a true or false. There's only two Booleans, true or false. An integer is a number without a decimal. It's a whole number. A float is a number that has a decimal. An object is the confusing data type. So typically, something that is an object data type will be a string, but technically speaking, something that is an object data type in pandas can be any valid Python object. And then we have a date-time data type, and this represents a specific moment in time. So we'll see examples of all of these coming up. There are other data types than these five, like I said, and we will explain them when it is necessary. All right, so the reason the data type is important, and the reason I bring it up right now, is that the data type tells us exactly what is possible with that value. So when you have a Boolean, you know you have a true or false. And there's only certain things that you can do with a true or false value. Just like if you have an integer, there's certain things you can do with an integer. Like you can't add an integer to a string, and you can add an integer to another integer or to a float, and actually to a Boolean. So the data type tells you, the sort of the essential properties is one of the most essential things to know about, each value in your data frame. So there's one other thing I want to mention, and let's bring in some data first. So just like before, we're going to read in the bytes data frame, and just look at the first few rows. Okay, so in pandas, the other reason that knowing the data type is important is that every column in a pandas data frame has a data type. So that means the trip ID has a particular data type. The user type column has a data type. That means that every value in trip ID is guaranteed to be of that data type, and here it appears to be an integer. Every value in user type, this is the weird one, is going to be an object. So this is the only one that doesn't guarantee you to be of a more specific type. So that's unfortunately confusing. So that's what I wanted to bring up here, is that every single value in a column, they will all have the same data type. There'll be one of these listed here or one of the other types that I have not got to. All right, so we will talk more about data types in just a bit. I want to cover missing values right now. So pandas represents missing values with actually three separate objects. So this is a little confusing again. There's not just one missing value representation. There are three different ones for different data types. So let's begin with the Boolean and integer data types. So these actually have no missing value representation. So if you have a column of Booleans, and for whatever reason one of them decides, or one of them needs to be missing, then you will no longer have a Boolean or integer column as a whole. So pandas will convert every single value in a Boolean or integer to some other data type, like a float or an object. That's unfortunate. There's no missing value representation for Booleans or integers. Floats do have a missing value representation, and this is nan. This is taken directly from NumPy. So nan stands for not a number. It is a singleton in the NumPy library. Object, so any column that is of object data type technically can be any three of these, but usually it's going to be none. Sometimes you see nan in an object because object can contain any valid Python data or any valid Python object. Next we have date time. So there is a missing value representation for date time, and it's this NAT, which stands for not a time. So again, Boolean and integer have no missing value representation. Floats have nan. Object is typically none, but can be all three. And date time is not a time, NAT. So there's a recent update to pandas. A long requested feature was to add support for integer or missing values for integers. So now pandas does have it's actually a completely separate integer type. It is different than the default integer type. But this new integer type is able to have nans. This is not important. It was just recently added to pandas as of the release 0.24, which happened in February of 2019. It's now March of 2019 for this recording. So this will get talked about at a much later time. It's just a very brand new addition. So just to be aware of that. Okay, so like I said, every column in a pandas data frame, the essential thing about the column, the fundamental property of a column is its data type. Okay, so we can retrieve the data type with the dtypes attribute. So this is not a method. You do not put parentheses after here. It is an attribute. And so it's just .dtypes, and we get the data type of every column. So first thing, before we talk about what's exactly going on, what's returned is you have to know the object that's returned. So pandas actually returns you a series. So this is not a data frame it returns a series with the column names in the index. So just in the last video, we learned about a series. It's composed of an index over here on the left-hand side and the data over here on the right-hand side. So this is a single dimension of data. The index is not a column, all right? So the index is not a column. It is just a single dimension of data. The index is simply a label. You really need to work that word into your vocabulary. So trip ID labels int64. Start time labels object and so forth. So this is a series. So all the columns are over here in the index, and their data type is over here as the value. So you can see we have a mix of integers, objects, and floats. And if we look over here, we can see, yes, trip ID looks good. That's an integer. User type is an object. So anytime you have strings, pandas will use this object. And the vast majority of the time, this word object refers to columns that contain strings. So it is a good assumption to make whenever you see string, or whenever you see the word object for data type, that it is in fact a string, although that's not always the case. So you might be surprised to see that start time, it looks like it should be a date time, but is actually an object. So pandas does not automatically convert. It does not sort of intelligently look at date times and understand that this should be a date time. So it is conservative in this case and does not make a conversion. You actually have to tell pandas forcefully to convert upon read. So I'm going to go back up here and show you how to do this. Let's just add a cell real quick. So if we do read CSV again, and we'll just get bikes. So read CSV has a tremendous amount of options available. So if I press Shift Tab Tab, I'll reveal the documentation. So there's a a parse dates parameter that you can tell pandas which columns you want to be date times. So there's two columns here, start time and stop time. So now when pandas reads this in, and I should have assigned this back into bytes. So now bytes has changed. The output looks the same, but when I look at the data type, I now have a date time. Okay, so there are no Boolean columns here. We'll see some Boolean columns later, but those are pretty simple. They're just true or false. You'll see the word bool, B-O-O-L, for Boolean columns. Okay, so I actually had already written that out. The next step, what are all those 64s that are attached to the data type? Right, so let me just put this out right here. What are all these 64s? So this stands for the amount of memory, amount of bits that each value in that column will take up. So every value in the trip duration column is a 64-bit 64-bit integer. Just like every value in the longitude start column is also a 64-bit object, but it's a 64-bit float. These are so pandas relies on NumPy for these data types. So an N64 is actually a NumPy data type. Same thing for float64 as well. It also uses object from NumPy, and pandas relies on NumPy as a base for the date time, but actually extends it to give it more functionality. So we'll see that in the time series. Now you can have different bits for your integers or floats. So you can make like a 32-bit float or 128-bit float, but the default is 64 bits, and that's typically what you'll see. Changing data types is a more advanced topic, and we'll get to that at another time. But for now, it's not really important to distinguish between like a 32-bit int and a 64-bit int. We'll just treat them as the same, and in fact, the vast majority of calculations will happen exactly the same. All right, so we've learned about data types and missing value representation. Let's do some actual. Let's get some more information about our data. So we're starting from very basics. Understanding what a data frame is, understanding what a series is. Knowing what the data types are, knowing what are the missing value representations. So once you have that, once you know your data types of the columns, then you almost surely want to know the number of rows and columns in your data frame. So the shape attribute will return a tuple of the number of rows and number of columns. So this is a very common thing to do right after you read in data and after you find out the data types. That's also an attribute. There's a size attribute that is not as, I don't really use this that much, but it's simply the total number of values in your data frame. So it's just the number of rows times the number of columns. Now, to get just the number of rows, I tend to use this len function. So you can just do len of bytes. So you pass this into the Python function len, and it'll return you the number of rows. So that's the canonical way to get the number of rows. There is an info method I want to cover right here. It doesn't provide that much information, and in fact it looks very similar to the output of bytes.dtypes. But what it does is, if we start up here, so one thing first, this is printed information. So this is you probably wouldn't know that when you first see that. It actually doesn't return any object. It literally prints out to the screen. So this is like a report that is printed. You can't capture this data with .info. It is simply printed to the screen. It says there's an index. It has 19 columns, and then it goes through each one of these 19 columns, and you can see the data type over here. So this is where it starts to look very similar to.dtypes. It does have the number of non-missing values. So anything here that is not 50,089 will have missing values. So you see here, all this longitude start looks like a few missing values, and some of these columns also have missing values. It does count up the data types down here. So there's 2 date times, 10 floats, 2 integers, 5 objects, and there's the memory usage over here tells you how much memory is stored. So one important thing here is that you see this little plus sign here. So Pandas does not actually return the actual memory usage. And that's because it has to do a little bit extra work to figure out the memory usage of all the strings. So any column that's object, it doesn't actually tell you the right amount of memory. I think it defaults to just some maybe 64 bits per value or something. I'm not sure. But regardless, if you have objects in your data frame, this is not going to be correct. So what you'll need to do, and this is one of the parameters in the info method, it says memory usage. So if you go down here and we give it the value of deep, then it'll give us the true memory usage. So if we pass in this deep right here, so we go down here, and all of a sudden, man, our memory has increased by 3 times. So string columns can dramatically increase the amount of memory in your data frame. So I mean, each character in a string in Python is 32 bits itself. So if you have a long string, you're going to rapidly increase the amount of memory. So this is not a correct number when you have object data types. All right, so that wraps up the chapter 2 on data types and missing values. All right, now if you want to learn more, please consider purchasing the book, Master Data Analysis with Python. This is Volume 1, Foundations of Data Exploration. There are 600 pages, 300 exercises, many projects, and detailed solutions for all of it. You'll learn a lot with this book, and that's a great way to practice all the material. All right, looking forward to the rest of the series.